Hi, my name is Maddie Gaines, and this is my Physics 2212 Lab 1 charge tapes at the Georgia Institute of Technology. The purpose of this lab was to use tape in order to observe the transfer of electrons between surfaces and to calculate an estimate of the charge and number of electrons that were transferred. The principles of this lab include using tape in order to model charges by assuming that each piece of tape had equal distributed charge, and in order to apply Coulomb's law using Newton's second law, which is force equals mass times acceleration, and Coulomb's law in order to calculate charging each piece of tape using the approximate dimensions of an atom to calculate the number of excess or deficient electrons per atom on a piece of charged tape. The charged pieces of tape repulsed each other. The charged pieces of tape were also determined to be positively charged. The charge in each piece of tape was determined to be about 1.34 times 10 to the negative 8th coulombs. Each piece of tape was determined to be deficient of about 8.37 times 10 to the 10th electrons. And as you can see, tape A was on the bottom, and that was what caused tape B to float. Each piece of tape was used to model a point charge. Air resistance is negligible, and I treat a long piece of tape as though it were a point charge with all the charge concentrated at the center of the long tape. Each U-tip has about the same amount of charge evenly distributed along the length of the entire tape. The system in my lab is tape B and tape A, and the surroundings are everything else in my room. The initial conditions, it was two pieces of approximately neutral tape also being equal in length, and a third piece of neutral tape that was stuck down on my desk. Tape B was stuck to the tape on the desk and ripped off quickly in order to charge it, which could either cause it to leave behind electrons or gain more electrons. The tape was then hung near several objects in my room and objects in general to determine its charge, and it was finally placed above the other piece of similarly charged tape A until a portion of it floated. This distance was measured to calculate tape B's charge. I observed that the U-tape was attracted to my hand, it was repelled by the other piece of tape, it was attracted to my cat, and it was repelled by a plastic toothbrush. I was able to reach that the U-tape is positively charged and it has lost electrons. I used the measurements to determine the measurements for the tape, and I determined first the force of gravity on the tape, which was about 0.00217 newtons. Then I was able to determine the charge on the tape as the acceleration of the tape is 0, so the force on it must be balanced, meaning the electric force must equal the gravitational force, since the only forces we accounted for in this problem are in the vertical direction, were these two forces. I then used the equation for the electric force to determine an equation for Q, and to solve for I got 1.34 times 10 to the negative 8 coulombs per piece of charged tape. We also assumed that the charge on each tape was equal. I used this data to come up with a few more calculations. I divided the charge of one piece of tape by the charge of a single electron to get 8.37 times 10 to the 10th electrons that I'd lost per piece of tape. I used the area of tape and divided it by the area of an atom to determine that there were about 4.21 times 10 to the 17th atoms per piece of tape, and I was able to determine the ratio of one electron for every 5.014 times 10 to the 6th atoms. So I used GlowScript to find the electrical charge of each tape in this slide. And then in this next slide, I use GlowScript to evaluate the force type on each of the tapes. So the blue arrow pointing up is the electrical force, and the yellow arrow pointing down is the gravitational force. Some issues include that the piece of tape were actually not point charges, but we just use that to model, so it would be much simpler. There's also some inconsistencies because of that. The charges on each tape are likely not exactly the same as we assumed, which also simplified it. There's some potential sources of error. Each tape was not equally charged, meaning that Q may have not been equal, and our calculations may have been skewed. So in response to this what if question, I basically would just say tapes would still repel each other, except for they would have a positive charge. So in regards to the why question, the point charge model disregards length and charge distribution across the tapes. It simplifies the equation so that the charges are at just point, leading it to be more inaccurate. The line charge model considers the length of the tape and charge distribution, which makes it more accurate and more like real life. This concludes the end of my lab report. Thank you.